Hello everyone, this is the video lecture for Calculus 3, section 16.8, Stokes' theorem. Aren't you stoked about it? Gotta make that joke. So, we have these formulas here. Integral of f dot dr, this is something we've done from way back in chapter 16, is now equal to the curl of f dot n ds. And sometimes I'm pretty sure they'll even rewrite this as curl f dot ds. So they kind of merge these two together. N is the unit normal vector. Normally here, like if, let's just say for a second, we got some kind of dome going on. It's a pretty common thing. It's oriented straight up, therefore you can have it just as a 1, and you don't really have to worry too much about it. I'm not going to go too far into all that, but essentially it's there either way. Okay. So let's get started on Stokes' theorem. What we're going to be doing is trying to make problems easier. That's the goal. Either we go from here to there, or we go from there to here. Either way, whatever makes it easier. So they start here with the double integral of the curl of f dot ds vector, and they want to know what that is. Given, see again that n is gone, so they kind of just mushed it in there with the s. We got f vector is equal to x squared sine z y squared xy. My s, my surface, is the paraboloid z equals 4 minus x squared minus y squared above the xy plane. And it says oriented upward. See how that orientation thing? Oriented upward. We had even talked about that a little bit in the last section. Okay, so in a way I'm saying positive is what I'm kind of getting out of that. Let's just go ahead and do it. So I think what they're wanting me to do here is convert this to an f.dr, essentially, which is good, because that's pretty easy. We've been doing that sort of thing a lot. In order to get this f.dr, the r is actually the outer rim, I guess you can say, of, say, like this paraboloid here we got. And so notice above the xy plane, so this is where we're cutting it off, obviously. And in a way, to orient upward, we're doing right-hand rule. So if you did it counterclockwise, this, I guess, the rim of the shadow, if you did it counterclockwise and you did right-hand rule, it would be oriented up, so that makes sense. That direction in particular is important because we're going to have a sine and a cosine, in the right spots. My radius should be, if you move all this stuff back over, or, no, rather, if you set z equal to 0, I'm sorry. Yeah, z equals 0. Then you move it all over. You'll get radius of 2. So you get a 2. Over here you get a 2. So let's find my r vector for the rim of this, that circle. It's actually quite easy. It's 2 cosine t, 2 sine t, and then 0 for z. Again, notice x, y, and z. Let me pause it for just a second. All right, and now we do the r prime, so we're finding the derivative. Cosine's going to go to negative sine. Sine goes to cosine. And of course, 0 stays 0. So when they're asking for f dot dr, obviously dr, r prime, same thing. We already have our f. It's right there. And so let me start putting it all together. So I've got x squared sine z, y squared, xy dot, and then we got this guy here, negative 2 sine t, 2 cosine of t, 0 dt. Notice that we have a dt at the end, and of course we're going to go 0 to 2 pi. Looking at it, we're going a full circle there. But the problem is that I still have x's and y's here, not t's. Well, notice that we got x, y, and z. These need to get plugged into here to get all t's. So here we go, big mess. 2 cosine t all squared sine of z is actually a 0. That'll be thankful here in a minute. My y squared, so I got 2 sine of t all squared. And then x times y. It's not going to really matter in the end because this one's going to get canceled anyways, but I wrote it anyway. So this one dot, sorry, it's going to kind of go sideways there. Negative 2 sine t to cosine of t 0 dt. When you start doing the dot product, this is a 0 here, so this is going to cancel with that. This is a 0 here, so this can cancel with that. So only 2 things left over here. So I got 2 cosine. I got actually 4 sine, so that's going to be an 8 sine squared t times cosine t dt. Definitely, we're doing the u substitution stuff. U is equal to sine, derivative that's a cosine, pretty simple. You're going to get 8/3 sine t all cubed from 0 to 2 pi. When you plug in 2 pi and 0, you actually get 0 out of this. So, well, you get 0 minus 0 is 0. So, sorry, the whole thing for just 0. 16,8,003. So now I got double integral of the curl of f dot ds, just like last time. My f vector is z e to the y x cosine of y x z sine of y. I wonder where they get this stuff from. I mean, this is complicated. They're really training us for something out there. And so then we got S here is going to be a hemisphere. I think we had a hemisphere last time there. No, it was a paraboloid. So this is a hemisphere. X squared plus y squared plus z squared equals 16. Y greater than or equal to 0. And it says oriented along the positive y axis. Okay. So what are we talking about here? Well, again, we have a hemisphere. It's going to be a circle. It's going to come out like this. It's kind of like a dome, I guess you can say. Didn't draw it super great, but it's close enough. Again, positive y. So notice here, if I'm going to do my right-hand rule correctly, I actually have to go this way in order for this to work. So what I did whenever I was doing my math, I actually did the flip. I was actually going to go the other way, but I'm going to go this way. It's clockwise, it seems. Again, x and z instead of just y now. And what I had done at the end, because I went the other way, I went counterclockwise essentially, I got a negative in the end when it really should have been a positive. So I'm going to actually go correctly here in front of you, if that's okay. Notice that we have this circle here. And how do we find it? I'm saying that my y is equal to 0, and so you can see my r is equal to 4. And to get that clockwise from the top going down, you're actually going to have my x is actually a sine. So for sine of t, my y is 0, and then for cosine of t. I'm pretty sure I'll get the correct answer out of this one. What I had done is I flipped those, and I got that negative instead of the positive answer. Notice again it says oriented positive y-axis. So you have to do your right-hand rule. You can't see my hand, but basically I'm trying to curl it around to kind of get that my thumb pointed out towards the y right there. And there's no way I'm actually going to draw my hand. So, sorry. I'm not that good with the drawing. So there's my derivative. Pretty simple. We've already kind of done that stuff. So 0 to 2 pi of my f. I need to rewrite it, of course. This is my x, my y, and my z when I start plugging stuff in. Notice that y e to the 0 is going to make it 1, so just times the z is going to be a 4 cosine of t. Trying to simplify here. X and y. My y, cosine of y is going to be a 1. So cosine of 0 is a 1. X, so I got a 4 sine t. And then the last one is xz times this. Sine of 0, 0, so I could just put a 0 there. Thankfully, that's a little easier. Times this guy. Yeah, dot this guy. Just go ahead and write that one back up. There you go, dt. This should do it. So notice that we got 0, 0, kind of like the last problem. So we got, what, 16 cosine squared t dt, going from 0 to 2 pi. And so what I recommend is actually using a calculator. Because I did not already technically do this, I'm going to real quick use my calculator. Make sure when you're using your calculator on something like this, it's got to be in radian mode. So I'm just simply saying cosine of x all squared. I'm not going to show you. I'm just going to do it right quick. 0 to 2 pi. Because again, we could use the integration tables. Or you could do all kind of different things. It's not too big of a deal. This is a common integral. And so I end up with a pi, 3.14159. Obviously, it's pi, so 16 pi. Notice that it stays positive, and that's the good thing. So your orientation really is important. That's why I was trying to stress this right here. Notice normally I would have said cosine and sine, and that's what I did on my paper. Well, I messed up at the end. So we got to make sure we're oriented it correctly. Here, clockwise, what appears to be clockwise here will give you that positive y when you do your right-hand rule. Okay. Next question. I got 16, 8, 007. So integral over a curve of f dot dr equals something. And so this is kind of interesting because now they want to actually find it, like I'm going to have to use the Stokes theorem backwards, or I guess you can say. So they want counterclockwise from above, and then they have this triangle. Let me try to write up what we have. So I've got my f vector. Sorry. My f vector is x plus y squared, y plus z squared, z plus x squared. And my C curve is this triangle 7, 0, 0, 0, 7, 0, and then 0, 0, 7. Okay. If you go to 3 dimensions here, essentially we got 7, 7, and 7, and so we're talking about this triangle right there. The problem is if I'm going to use my curve, I'd have to use the outer edge, the rim, one integral, second integral, and third integral, and I'd have to make lines for each one of those, and it is just one big mess to find out what's going on. And so rather, I'm going to do blah, 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 dA eventually, which ends up being this guy as my shadow. That's going to be a dA in a couple minutes. So that's my goal is, again, 7s. Again, is that shadow down here. Let's now put it all together. So I'm going to now convert this to double integral of, over my surface, of my curl f dot ds, essentially. Well, really the curl part's going to be a big focus, and so let's start working on our curl of f. So that's going to be grad cross f, and so then I've got del del x, del del y, del del z cross, and then I got this f vector. Here we go, x plus y squared, y plus z squared, z plus x squared. Okay, here we go. Always a 0. Derivative in terms of x is a 0, k. And then in terms of x here, I got a 2x. It's going to be a negative in the j component. In terms of y, it's going to be a negative k, 2y, k there, always a 0 in the middle. And then in terms of y, you'll have a 0. In terms of z, you'll have a 0. Z here, there's a negative I component, so negative 2zi. And so I got negative 2, let me get my letters correct, negative 2z, negative 2x, negative 2y. Yep. Okay. So, that looks a little funny, doesn't it? But this is my curl f. And so what I really want now is, let's go back to my original one way back in the beginning where I said dn, I'm sorry, .nds. So I want to actually get my n, that's my normal vector for the surface. If you remember the surface I had just drawn it a second ago, it's basically the normal vectors this way. Because it's 7, 7, and 7, it's a 1-to-1 ratio everywhere. And so if you were to create a plane for this, it essentially is like, what, 7x, 7y, 7z equals, I don't know, I think it's 1 or 7 or something like that. Or maybe it's like 49. I don't know. Anyways, it's something like this. But my slope here is 1, 1, and 1, or 7, 7, 7, or whatever you want to call it. I'm going to use 1, 1, 1 because it's my unit normal vector, essentially. Not that 1, 1, 1 will exactly get you unit, but, well, it's at least in the right direction. So, I know if it sounds a little weird, like I'm just making stuff up, I'm kind of a little bit, but not entirely. You got to just play with it, you know. So 111 DA. So again, this is my cap N. As long as they're all the same, at least that's going to help us a lot. And so we have to go and plug in here in just a minute, because obviously we got a dot product here. Everything is times 1. So just orient it correctly. Got negative 2x, negative 2y, negative 2z. DA. I can't have a Z hanging out, so I've got to go back and change that. I actually should just go and find my plane equation, if that's okay. So I don't know about the 7s in particular. Let's actually do this properly. If I were to have x plus y plus z equals 7, does that make sense? And I would say yes, because again, I have my... Yeah, this is it. I like this much better. Okay, forget my 7s. I was thinking something else. This is fine. 1, 1, 1. I like it. So I got 1, 1, and 1. There's your normal vector. There you go. Okay, we're great. So for the 7 here, notice that if I take these instead of equal to 0, x equals 7, take these two and equal to 0, z equals 7, da-da-da-da, it all works out. So forget what I was saying about the 7s right there. Just go with the 1s. There you go. Everything's fine. That's how it works. So we need to replace that z. I'm going to go ahead and move these guys over. So z is equal to 7 minus x minus y, and therefore I could just toss this in right there. And so 7 minus x minus y. dA. Okay. So dA, we're now looking again at finding my area. Well, remember that my shadow was at 7 to 7 here. And so I need kind of like my area of that. Well, let's say y is equal to 7 minus x. Essentially, I took my z and set it to 0, and dimensional reduction moved the y back over, and there you go. There's your equation. Easy stuff. So let me go ahead and distribute that to make it a little bit easier. Combine like terms. So I got a negative 2x. I got another... Oh, 2 negatives make a positive. It's actually kind of weird because they actually cancel, make a 0. Same thing here. I got 2 negatives make a positive, and if that one cancels, so minus 14, I guess. dy dx, 0 to 7 minus x, and then 0 to 7. Well, the negative 14, we don't even have a y or anything, so you just toss a y on there. The 0 would cancel, so I got a negative 14, 7 minus x dx. You can go ahead and distribute to make this a little bit better. So then I got technically a 14x minus, then 17 times 4. I'm sorry, 7 times 14 is a 98. Dx. Go ahead and integrate that. So then I got 7x squared minus 98x from 0 to 7. The 0 is going to cancel. Go ahead and toss the 7 in. So 7 times 49 minus 98 times 7. And I get a negative 343. And that's the answer. Keep cruising. 168010. They want the integral of f dot dr. Again, my f vector is 6y. xz, x plus y. My c, my curve, is the curve of the intersection of the plane z equals y plus 6 and the cylinder x squared plus y squared is equal to 1. Now this is just weird looking. Let me try to draw this as best I can. We got a cylinder going on here. And then we have a plane. Let me try with a different color. We got a plane kind of like going this way, let's say, where when it's intersecting, use a different color here, it's intersecting right here. So you can see that it's like, it's the same, it's a circle, essentially. If you're looking straight down, it looks like a circle still. But it's tilted just a tiny bit, and so it's not going to be exactly the same for that. Let me show you how this thing works. This is actually going to work out pretty easy in the end. I'm going to just go right for my R. So this is my X, Y, and Z. Notice that I'm going to go to polar mode. So my radius is going to be a 1. You can see that. So 1 cosine t. My y is a 1 sine t. And now, what is z equal to? This was x, this is y. But what is z equal to? Well, you have it right here. You see that? Z is equal to y plus 6. Whatever you have for y, plus 6. And that's your z. So that's good. They basically created that for us, and that's good. So derivative dr essentially is going to be a negative sine t, a cosine t, and then we got a cosine t. That 6 goes away. So integral, definitely 0 to 2 pi of my f. Original was 6y xz x plus y dot, now this guy, negative sine t, cosine t, cosine t. Okay. Well, this is x, y, and z. I can take these and plug them in here. Have you noticed something that has not gone on? I'll tell you in a second. Cosine of t, and then times sine of t plus 6. And then finally, my x plus y is going to be a cosine of t plus the sine of t. Whew. Almost there. Cosine. Running out of room. Another cosine. Okay. So multiplying all this together is going to be one really big mess. But let's go for it here. I got these guys at the very ends. So negative 6 sine squared t plus, I got this chunk multiplied by that guy. Notice that's going to be a cosine squared. So I'm going to have a cosine squared t sine t plus 6 cosine squared t. And then finally these guys and this thing, put them together. No comma needed. I don't know why I have a comma there. Let me erase it. It's a scalar. Plus, sorry, it's also going upwards. It's just my drawing tablet here. My cosine squared, and then sine and cosine. So I'm going to go with sine t, cosine t. Phew, all this dt. So you can combine some like terms. There's a 7 there. You could probably convert that over to a 1/2 sine of 2 theta. Or 2t, basically. This would be a u substitution. Oops. It would just be just cosine, basically. So du would make it negative sine. This guy again... in fact, you know what? No, they're not going to work together. It's okay. You can actually find this integral by itself would probably just be a pi. I think we already did that earlier. And you can, instead of combining these, you can work with these two guys to make 6... actually, it's going to be cosine. 6 cosine of 2t. Yeah. and then you can integrate this one, there's a pi, and there's this guy, all together. Well, you can kind of probably guess what I actually did. I just put it all in my calculator. And the whole thing actually ends up just being a pi. There's your answer. So we're done. Thank you very much. Have a great day.